Hide this. Oh, we really haven't talked about pointers yet either.
I mean, I think we were just gonna do like a quick overview because I know what you're talking about.
Okay,
I just
you're roughly got it.
yeah.
Okay, so let's start with the idea of structs. So, what would you say a struct is?
Um, isn't it just a way of storing like organized data?
Okay, give me a little more than that, or give me an example.
Like if I wanted to have like if I wanted to have a user, then I would make a struct user and store like their name and their email and password in
Yep,
that struct.
yep. So a collection of name value pairs, right? So
Yeah.
we can say like a dictionary in Python. And then we might throw in here, we'll do a, you see, I think I've asked you before, you've seen Big Bang Theory, right?
Yeah.
TV show. So like Sheldon. So here's a fun fact from Sheldon. And maybe we've talked about this before. Um, oh, what languages, let's see, what popular languages support structs? Can you give me a list of, let's call it high level compile languages? So C, obviously, right? What about C++? Does
Yeah.
that support it?
Yeah, I think so.
All right. What about Java?
I'd assume so.
Nope.
No? Okay.
Not Java. We'll talk about that here in a second. C sharp, yes. Swift, sort of.
Yeah.
You could almost say with Swift, the answer is almost always sort of.
Yeah.
An Objective C. Have you done anything with Swift?
I no, I've not used a Mac long enough to need to.
Well, it's
So
not even using the Mac long enough. It's more of a, using a, doing anything
or
for iOS. If you were
yeah.
writing something for iOS,
Yeah, if I'm doing something for iOS, I'm probably using like React Native or something like that
oh,
because
you're
it's
using some
easier.
cross-platform crap,
Yeah, or like Flutter, I think is one of them.
right? Okay, so this is a little bit of an interesting connection to what we're talking about up here, and it's actually linked to the idea of pointers.
Hmm.
Um, let's see, where am I at here?
That's really far back.
Trying to see where my, there we go. Why doesn't Java have structs?
Since it's object oriented. I
Well,
mean, C sharp has it, so that's not a good explanation.
and C++ is object oriented as well.
Yeah, yeah, and
So,
Objective C, obviously.
so let's ask you this: how can you pull off structs in Java?
Aren't they just enums?
No, an enumerated type would
Oh yeah, I mean,
that would be different. But
yeah,
you told me that a struct is basically a collection of name value pairs, right? So
yeah.
I can say like, here's a player, and a player has a name, a current score, a current rank, whatever, that kind of stuff. So it has two or three, four uh, field pieces of information associated with it, right?
Yeah.
So how is a struct different from a class without methods?
I'm gonna say it. I mean, you can't have like a new like. Can you have structs in structs? Like you can call
Yeah,
like
you could.
you
You could
could.
have,
Okay.
you could have a struct called uh, account holder, and then inside that have one of its values be a struct called person, where a person is a first name and a last name and an age. Yeah, you,
Okay.
yep.
Um.
So here, isn't a class that we choose not to write methods in effectively a struct, i.e. the fields allow us to store name value pairs.
Yeah.
That's a true statement, right?
Yeah.
So we're going to say sorta. So sorta, while it allows us to hold the right kind of info, the way classes behave is different from the way structs behave by default. How variables are passed. Objects are passed by reference or by address.
Yeah.
By default. Structs are passed by value or copy by default. Right? So even though we might say that a struct can be roughly represented in Java through a class, it's not quite that cut and dry, because if you came to Java from a C++ background, you might be pretty used to passing a struct to a function, maybe making changes to that struct and having confidence that those changes would not have a permanent side effect. Mm-hmm. So in Java, you might be used to, I'm sorry, in C++, you might be used to passing a struct to a function, making changes to that struct, and having those changes erased automatically when the function ended. Because you were dealing with a copy. That makes some sense?
Yeah.
Whereas when you get to Java and you try to represent structs using a class without methods, and you pass it to a function, you end up with, and you pass it to a function and make changes, changes, those are permanent, i.e. have side effect.
So like your structs are stateless and classes are stateful throughout the entire, I mean,
yeah,
I get what you're saying.
I don't even know that you need to classify it as that. I mean, you know.
Well, I mean, yeah, because structs are technically stateful but it's just not stateful throughout the entire application.
Yeah, I'm just not sure that stateless versus stateful is related directly to structs versus objects. Really, this is just a pass by value versus pass by reference exercise. Now, in a language like C as well as C++, and we'll look at this with syntax here in a minute, we have the power in C to pass a struct. And we'll actually, why don't we just go look at this as by an example. We'll just kind of put it all in there. So I'm gonna, let's just make a directory here. I went ahead and I created a couple of things for drivers, and since that's the direction we're going. So I don't know how much we'll make it into these today, but we already have some buckets to get into. Have you worked with Makefiles before?
Not really. I've never really.
You're aware of their existence.
Yeah, I know what you're talking about.
Okay. Yep. So we'll look at those first. So I kind of said, let's do a Makefile tutorial at some point, and Then we'll think about a simple kernel module and then actually a driver. Go from there.
Yeah.
So I just got us ahead a little bit so we're ready for wherever we go. Just because some of the things that we're going to write in here take a little bit more time, and I'd rather, I mean, some of the stuff is worthwhile coding in real time so we can talk about the nuances, but some of it I want to be able to say, okay, here's some code that works, let's walk through it and see why.
Yeah.
Rather than spending 30 minutes writing stupid stuff and debugging it when we only have an hour, hour-ish.
Yeah.
Okay, so I'll just go ahead and make a directory here for, let's call this pointer struct tutorial. All right. And I'll go ahead and open up.
Just got to use your code period. And you don't have to worry about it.
Use my what?
You just type code space period, and
Oh,
then it'll
true.
just. I'm looking out for you. I use VS Code too much because I write in JavaScript most of the time.
My VS Code is basically broken right now. You see this?
Oh yeah.
And the
It
problem is because I run it. It's broken because of a virtual machine.
Yeah.
It's fine. I'm not even going to use it.
Probably turn off graphics acceleration, which might fix it, but
I'm not going to worry about it. We're writing something pretty simple, so we'll just do it in PI. So we'll do a main.c, and we'll include standard io.h because we're writing a C program here. So we use standard IO versus C++, which uses IO stream.
Mm-hmm.
And I'll say int main, int argc, char pointer argv. We've talked about what those two parameters are, right?
Yeah.
Okay. Eclipse. I'm sorry. When I hit escape, it shows me my floating bar for Zoom at the top.
Yeah.
It took the thing away from this. All right, so we'll go ahead and let's just start off with an int a equals 5. We'll say int b is equal to the address of a. So this is our special syntax for getting the address of a variable.
Yep.
We'll say int c. Actually, this is not an int b. This is an int pointer b. This is a variable capable of holding an address.
Yeah.
So we just want to get used to the special syntax for dealing with memory versus not dealing with memory. So now if I do a printf, a is equal to %b, b is equal to %p, and %a is equal to %p, star d is equal to %d. So we'll say a, b, oops, close this here. A, b, still doing it wrong. The address of a star b. And we'll throw a backslash n here at the end. Kick it down the line. All right, so define a normal integer a equals 5. Define another variable of type int pointer. So this is capable of holding the address of an integer. And we're going to set that equal to the address of a. Go ahead and print out. Have you used printf before?
Yeah.
Okay. So we'll print out %d's for a decimal, %p's for a pointer. So we should get a 5. We should get the address that lives inside of B, which is the address of A. Then we should get the address of A here, which should be the same as B. These should be the same addresses. And then we should get the value that lives at B by following that the decimal that lives at star B. All right, makes sense how those are working? So you see the syntax we have over here? Thing is A. Second, A is the value of A, which is 5. B is the value of B, which is an address. The next one is the address of A. So this says go ahead and don't give me the value of A, resolve that, or I guess deresolve that and give me the address, dereference it and give me the address. And this says reference it and give me the value that lives at the address stored in B.
Yeah.
So we'll go ahead and compile this guy. Let's call it main.c. So there's my A is 5, B is an address at A, or I'm sorry, the address of A is the same as what B is holding. And then the value that lives at B is the same value that lives in A, which lives at this address. Make sense?
Yeah.
All right, so now let's go look at structs in here. So I'm going to go ahead and I'm going to write a function. We'll put the function up above here. So I'll do void, call this guy change struct. And this guy will take in a struct. We'll call it person named P. I'll leave it as a capital. That's okay. All right, and we'll go ahead and say p.fname is equal to woot. That. And then do nothing with it. Let's go ahead and just give myself another function that this is called print. This guy will take a struct person P. And we'll go ahead and say print F. Percent S space percent S P.fname, P.lname. Kick it down the line here. And then we need to go ahead and define our struct at the top. So we'll say struct person is going to have a char pointer F name and a char pointer L name. We'll just say those two things. And down here in main, we'll go ahead and create a struct person P1. Say P1.fname is equal to Mike. P1.lname is equal to Whitman. And then we'll call print, what do we call print person, and pass it P1. Like that. Let's just test this, make sure it's working. Print person takes in a struct and passing it a struct. It prints out the two strings. person is that. All right, let's go see what it screams about. Okay.
Oh,
Not
wow.
too bad with VI. I haven't used VI in, well, actually, I'm lying. I do use VI pretty often, but I haven't used it to write something that long in a long time. All right, so far so good, right?
Yeah.
Now what I'm going to do is I'm actually going to inside of, actually I'm interested in the current value of GCC. I might show you something else here in a second. I'm going to say print person P inside of here. Notice that print person is actually defined after change struct.
Mhm.
Historically in C, this would give me an error during compiling because the old
Oh
C
yeah,
compilers,
because yeah, print person is.
yeah, it's not defined till afterwards.
Yeah.
So it's called a one-pass compiler. Do you know what the fix is for that?
It's just move change struct down below print person.
Yeah, but is that safe? Is that safe to do that? Because you might have a situation where you have functions that are reliant on each other, right?
Mm-hmm.
So then you can't fix it the way you're suggesting, where you just put them in the right order and hope for the best, right?
Yeah.
So what's the other fix?
Trying to think. I don't think I.
Okay, we'll talk about it here in a second, but I'm
Okay.
just more interested. I'm actually going to guess that. See, this is an interesting conundrum. Does modern GCC treat C using the old standard, where even though two-pass compilers now exist, and what I mean by two-pass compiler is it makes an initial pass through the code to pick up all the symbols. Here's
Mhm.
all the crap that exists. Then it makes a second pass through there to actually do the syntax checking. That way it would have actually known about print person before it got to the logic within whatever I called it, change struct or something like that. All right. So definitely old school C would give me an error because
Mhm.
it was a single pass compiler. And when I try to call a function that hasn't been defined yet, it's going to be pissed. Right.
Yeah.
Now, it's possible that GCC, being a newer style compiler, uses a two-pass compiler. More than likely, it probably has uh, a command line option that would allow me to treat it as older style, kind of the CC version of it.
Mhm.
So let's see, what's my guess? Do I think this is going to work or not work?
I'm gonna put my money on that is a two-pass compiler.
Well, I'm positive it's a two-pass compiler.
Well, yeah, I'm gonna say that it's gonna give you a warning.
Okay. I'm actually going to. The way you're thinking about it, I think, is accurate.
Mm-hmm.
You're suggesting that it will recognize that it's possibly a problem, but it'll let me get away with it, but it'll give me a little feedback.
Yeah, it'll say,
I,
"Don't do that ever again."
I actually think it's just going to let me do it. No warning.
Oh,
Dang it.
do I win $1 million?
That was a good one, though. Yeah. So we did still get an A dot out
Okay.
from this guy. Oh, actually, no, hold on. It didn't compile.
Oh, it didn't? I mean, it gave you warnings, but it just didn't compile.
It did not compile. If I do a remove A dot out. Oh, hold on. I never called. It did compile.
Oh, okay.
Because I never actually called that function.
Oh, okay.
But let's just go in and let me show you how to fix this first.
Okay.
The historical way. It's also, in fact, let's actually put this in our notes over here. Fixing one pass compiler issue. If we call a function before we define a function, we could get a compile time error, or more modernly, a warning. Since modern compilers are two pass. How do we ensure that all functions are known before we call them? Two options. Old school, write prototype functions at the top. Let's go look at that.
Oh, so you're basically just telling the compiler, hey, shut up, this actually works.
Oh, what I'll do is I'll take all of my functions here. Oh, what I just did. Get this guy to open now. It'll be friendlier to do this in there. It's so such garbage.
You're gonna have to go back to Notepad++.
All right, so and once I look at it, it'll tell me what the copy command was. Shift Control C. Okay. That would be Shift Control V. All right, so what I'm actually going to do is I'm going to take all my functions here. And I'm prototyping them at the top.
Okay.
All right, main already knows. That's why I needed to do it for two. All right, so it knows that there is a change struct function. I actually don't need to tell them about P here. I could just say it takes in a struct person. So if you're the compiler, you're going through here and you're saying, if you're a one-pass compiler, you combine, you're picking up symbols, you're saying, there is a function that returns nothing called change struct that takes a struct person as a parameter. Got it. I'll remember that. There is a function called print person that takes a struct person as a parameter. Got it. I'll remember that. We don't have to rely on the fact that these two might rely on each other because the implementation doesn't come until later on. Does that make sense?
Yeah.
All right, so that way when we call print person, it's heard of it because we prototyped it up here.
Okay.
Does that make sense how that works?
Yes, you can just overwrite like functions at runtime. So like if I have my, or do you have to, because it doesn't really make sense that you shouldn't have to define it as a like prototype or something, or is that just kind of like?
Oh, we still have the same error. Hold on. I haven't finished fixing it. I'm gonna, I can prototype my struct as well.
Okay.
I think it'll let me prototype a struct person. I think I can just do that. There will be a such thing as a struct person.
So
I mean, realistically, maybe we would say we could just write the struct above here, but then we're back to that same problem as you mentioned earlier, is what if a struct relies on another struct? Because you can have a struct inside of a struct.
Yeah.
Okay, so we basically have a prototype section up here. Things to come. All right, so this is, we're going to call this guy old school. Isn't that how they write it? Don't they say it like that?
I mean, I don't know. I'm not the person you should be asking.
Well, I'm not the person either because I am old school. so this wasn't old school to me. This was just how you did it.
Well,
when I started using Linux before it had a X windowing system. Just everything was from the terminal. I prefer it. Although I'll tell you what, I used to use Emacs for my editor,
Oh,
and I've forgotten how to use it. And what's funny is VI has always been considered to be like the hard to use editor, right?
yeah.
So that's the one that you feel like you're really using your computer. VI, I'm much more comfortable with.
Oh, yeah.
And the historic reason for that, do you know who VI was designed for?
It was designed, wasn't it designed for I'm trying to, I mean, well, I mean, it wasn't designed for a graphical interface. It was designed for just having a
Oh no,
like a
VI predated X Windows by a lot.
well, of course.
VI was like Unix 1.
Yeah. Wasn't it just didn't it used to be just I and then it or
Well,
no, it
okay,
wasn't.
have you used VI or do you?
Yeah, I used Vim, but
Yes.
VI interchangeable.
Okay, so like when you want to write a file, you hit escape and then colon WQ, those stuff. You give it commands, right?
Yeah.
Okay. So the idea, the reason, and so a modern day person who's used to going up and hitting file save and all that crap, they look at VI and they're just like, why? VI is actually it was the original mindset was for touch typists. You didn't
Oh, yeah.
have to take your fingers off the keyboard in order to save a file, make changes, things like that. So everything was based on, shortcuts. Now
Yeah.
you end up going and you use the mouse first, and then you learn the shortcuts after the fact. Where
Mhm.
with VI, shortcuts were the way you did it. It's kind
Yeah,
of
that's why I like Vim and like NVim and stuff like that is because I can do it all from my keyboard.
right. The advantage of Vim over VI, and I think we saw it here with this guy. If I start pressing, I can move through it like this. But if
Yeah.
I go into insert mode and I start pressing the down, I get messed up stuff.
Yeah.
Where Vim, I think, lets you get away with navigating your document, using the arrows. It says, look, I think I know what you mean here.
Yeah.
I'm not crazy symbols and stuff. And I'm sure Vim is actually installed here. In fact, actually, I'm interested. Oh, interesting.
Still using apt-get? You're typing those extra 4 characters?
Oh, what, you only have to type app now?
Yeah, you only have to type apt. It's crazy. Technology is crazy.
It's true. Oh man, look at color codes it.
Exactly.
Beautiful. Oh, I'm in insert mode. Oh, even look, I'm moving all over the place. Oh, it's this like cheat style, but I'm gonna use it.
Okay, exactly.
All right, so we have our prototype section up here that lets the compiler know about the crap it might run into. I need to make sure I call change struct down here. That's the thing I didn't do. So we'll call it change struct P1 and then print person P1. So there's our Mike Littman, Woot Littman, Mike Littman. So evidence there is that when we called, oh, you can actually scroll the mouse.
Yeah.
Oh man, that's garbage. So that's just evidence here that when a struct gets passed in to a function, the default way it's passed in is by value. We made a change to the struct here, proved we made a change by printing it out again, right?
Mhm.
But then when we printed it out here at the end a second time, we saw that that change was not permanent.
Yeah.
Make sense?
Mhm.
Now I can do a void change struct address and have this guy taking a struct person pointer named P.
Oh, and then you can just write to the pointer.
Correct. Now I can
Yeah.
say star P dot F name is equal to woot. Print person star P. because I have an address, right?
Yeah.
I'm taking an address of a person, and print person expects me to give it a struct, not the address of a struct, a struct. So I give them the actual struct by saying star P here. So now I can go and say change struct address. Now, what would I pass to change struct address?
You would want a P1 pointer, or no, and P1.
Yep. Good. Actually, interesting thing. I'm wondering, does this exist in Seattle? I might be lying. I'm going to test the syntax here real quick. I think that's a C++ only thing, the arrow syntax. Have you seen that before?
I think so. I've worked with more C projects than C++.
In C++, those mean the same thing.
Yeah.
But I'm interested. I don't think the syntax is supported by C, the arrow thing.
I wonder if GCC might just kind of say, you know what, that's okay, and it'll just fix it for you.
If I allowed it. Yeah. So there's my evidence of the permanent change.
Yeah.
I am interested though. Let me check something here. I'll make sure I give you decent info. C language.
So I guess it is just kind of like a thing now.
Yeah, well, no, it looks like it's part of the C language. Yeah, it dereferences the dot.
Nice to know.
Yeah, and it's possible that's true. Because my C, I started coding in C a couple minutes ago, and I just don't remember if the arrow was something I regularly used, because I definitely use the parenthesis star syntax pretty often.
Yeah.
And so the question is did I use it pretty often because that was the only way to do it, or because I was a 9-year-old kid who I saw it in a book and that's how I learned to do it? I don't recall. But whatever. All right. So we see that by default, structs are passed by address, while as are passed by value, whereas objects, which we aren't looking at here because C doesn't support objects, but we know that in at least in Java, but it's true in C++ and in C# that objects, classes, are passed by address. So we wouldn't have to do this special crap to change the value of a struct. But it's an important thing that we need to look at when we talk. Well, we need to think about when we talk about C. All right, we need to make sure that the types we're passing around are the types we expect. And this is really the power and the maybe I'll say the problem with C and C++ from a modern programmer perspective. Modern people, when they learn programming to start, they are learning it with a newer language that has already moved past some of this decision-making stuff. We might say that an object is big, right? Probably the example I used when we first started meeting was like, if we think about, an object kind of like a house. If you were having a party at your house, you wouldn't hand me your house and tell me to open the door at 8. Instead, you'd give me an address. You'd show me where I can find your house, right?
I do remember we talked about that.
Yeah, that does make sense because houses are heavy.
Yeah.
Right. Now that doesn't mean that all objects are so bloated that they're that heavy. They're that memory intensive. But in general, we can probably say that if something's an object, it probably takes up more space than a memory address. That's probably a true statement, right?
Yeah.
Okay. Now structs, realistically, we could probably say that the same is probably true, right? If we say that most structs have at least two elements in them, right? At least name value pairs. And let's just say that the common type is an int. Let's just say they all have at least two integers in them, just as our example. And if the size of an int is 32, that means that the struct itself, even if we omit the idea of the overhead for organizing the struct, is going to be at least 64 bits to pass that struct around by value.
Yeah.
Right? Where on an operating system of any, let's say a memory address might be 32 bits, 32-bit memory address. So we could even say that for structs, it probably should have defaulted to pass by address. That would have been the smart way of handling it, because we would have said that, hey, you know what? Structs are usually going to be heavier than a memory address. It's just the way it is. But because the default behavior of structs is to pass by value, probably because of the lineage when they were first created back in the C language, they are passed by value, not really paying attention to how big they might be, which is actually kind of funny, because back then memory was at a premium and it was expensive. So you would have thought they would have passed it by reference regardless.
Yeah.
Instead of using the memory twice, because it's already using the memory, right? It's stored somewhere in your system memory. So if it's 64 bits, if you're storing two integers, you're storing 64 bits somewhere. That's done. That's a done deal. Now you could save yourself 32 bits if you have a function and you pass a 32-bit address to it where you can find it, rather than a copy of those 64 bits. Okay, so we can go back and say woulda, coulda, shoulda. They maybe designed it incorrectly, and maybe there was a rationale of why they did it back then. But in any case, structs were passed by value, whereas objects are passed by reference. Now, I mentioned earlier that if we think about structs, I said structs are kind of like a dictionary in Python. So let's actually throw kind of like a dictionary in Python. Dictionaries are passed by reference. I didn't put that there because I didn't give you the punchline until the next screen, right? So in Python, dictionaries are actually passed by reference, which makes some sense that that's how they would be passed. Okay. And I'll just kind of jump forward here a little bit, showing you something that we will be looking at. So here's an example of a struct that is historically used for writing drivers in Linux. There's actually a GNU version of this that's significantly cut down, because the idea is that, hey, there's a bunch of crap in here that you're probably not going to use. Yeah. Let's say that 98% of the time when you're filling out this struct, you could almost think of a struct in this use as kind of like a form you fill out. You go to the doctor's office, they make you fill out the couple of pages of a form, and some of this stuff you're like, you just leave blank because I have nothing to say here about whether or not my dog has glaucoma or something like that. So with that in mind, we can imagine that even though they've given us a zillion different things we could fill out on this form, most modules, we're going to start off with this idea of writing Linux modules, most modules aren't going to require all of those. Most of them actually require like 2 or 3 things. So there's kind of like a simplified version of this struct that is a address equivalent to this struct. But this is a good example from hey, how fat is this guy? Because notice, this shows us from before, we have a struct called file operations. One of the first things is who's the owner, which is a struct called a module. Another thing is here's a pointer to a function that takes in as a parameter a struct file. So we have structs inside of structs inside of structs. This guy's got a pretty fat ass, right? Is what it comes down to. It would be in our best interest to pass this guy by address, but by default, it's not. All right.
Okay.
But you do see plenty of examples in here where, like, you know, this read function takes as a parameter a struct file pointer. So we see that we're using good programming practice fairly often when we're saying, look, I'm going to say, give me a pointer to that struct. Maybe my rationale is because I want to use less memory. Maybe my rationale is I want to make a change to that struct. I want to have write privileges to that struct rather than get a copy. All right. But punchline here for us is C and C++ empower the programmer to make these choices. And in order for us to make these choices, and maybe they're not the hardest choices in the world to make, but we need to have our mind wrapped around the details around these choices. So in C, structs are passed by value. If we want to change the value of a struct inside of a function, we better pass the address of it.
Yeah.
All right, makes some sense?
Mm-hmm.
Okay. Ninja, there we go. All right, so there's some examples of addresses and structs and crap like that in C. So any questions on this stuff?
No, I don't got anything really.
Okay. So I'm going to go back one level here and let's go and look at our Makefiles. And you're good to go a little bit past 11?
Yeah, I've got time.
Yeah. I can't go tons, but I can go a little bit. All right.
Okay.
So, so let's say we have a little example here. So I have a couple of different classes here. So I'm going to say more factorial CPP. So I have this factorial. So this is a C++ example with a Makefile, but it'll be the same difference. We'll be doing C stuff with our modules. I don't know why I did it in C++. Oh, this actually reminds me of the other shoe that needs to drop. Didn't I write it in here? Where's my prototype thing? Didn't I write a slide dealing with prototypes?
No, I think we just talked about it. I don't think we ever made a slide about it.
All right, so pass, let's see, what was it called? Two-pass compiler. I definitely wrote a slide dealing with two-pass compilers.
I'm not sure that you did.
Was that all in my head? All right. So historically, C had a two-pass compiler, which, oh, had a one-pass compiler. Which only went through the code once to pick up symbols. So we had the issue of getting errors when we called functions that hadn't been previously defined. Solutions to this, old school solution was prototype the function slash types at the top of the C file. So it could read in all of the possibilities before it hit any implementation code. Newer-ish school. Should we spell that right? So what would be the upgrade to that?
I mean, just use the 2-pass compiler and then.
Okay,
just,
so let's assume we're still using a 1-pass compiler. We can either write prototypes or we can do what? Which is sort of kind of the same thing, but it is something you've definitely seen. In fact, you may have seen it about a minute ago when I was on that other screen.
Maybe, I don't know. Like, I guess you could. Oh, yeah.
So what's a header file?
So it's like
basically has our prototype stuff in it. And then we just pound include it in our implementation or in our, implementation file. This is like a historical third cousin to the MVC design pattern. You remember what MVC was?
Isn't it having like all of your stuff in like having your UI separate from your logic, separate from your other stuff?
Yep, model view controller, keep the interface, data, and code in different places so it doesn't get too messy. All right, so really header files from a computer programmer's perspective, we might say, you know what, these guys are a little bit inconvenient. For every C class, I need to, or every C file, I need to write a header file too. But the header file kind of reinforces that idea that we have prototypes, that we have functions that we want to make sure are included, and then it makes it convenient. What else does a header file allow us to do? What other benefit does a header file give us?
I mean, the ability to use like other people's programs, I guess.
Right, and also use the same functions in multiple programs or multiple codes, right? So like, the top, whenever we're writing something that deals with IO in IO screen, we include standard IO.h. Well, somebody wrote a standard IO.h, and there's a corresponding, we presume, standard IO.c file, right? Mm-hmm. Standard IO.h included all the prototype functions that exist, and those guys are actually implemented inside of the standard IO.c file, which ultimately gets linked in when we build our executable during compile time. Make sense? So it allows us to expose our libraries to other people. Okay. So in this Makefile tutorial, we'll at least go through this because this will set us up for doing our module next week. So in our Makefile tutorial, here's just a little factorial function thing I wrote. So we have a header file for this guy. So what do I call it? Oh, I didn't make a header. That's fine. All right. Oh, I made a header file for functions. So inside of functions.h, I've defined that there's a function called print hello and another function called factorial. So inside of functions, inside of my factorial.cpp, I went ahead and defined my function factorial, which just calculates the factorial of a number, whatever, does some logic crap. And then I also have another guy here called main, actually called hello. So hello CPP. This just prints out hello world. Actually, that's a different file. I think it's the main one that I was doing. Okay, so notice in main, this guy also includes functions.h. So I'm bringing in that header file in two different things, and I'm actually implementing my print hello in what, the hello CPP?
Yeah.
Hello. Yeah, there's my print hello inside of hello CPP. All right, so I've implemented one function in here. I've implemented another function someplace else. They both include functions.h. And then main brings that all together. It includes functions.h as well. So this kind of like prototypes the functions that are available to me, which were written inside of factorial and hello, right?
Yeah.
And then I call them in here and it gives me the factorial some number, blah, blah, blah. Okay. Now, when we could go ahead and compile this and we could do something like G++ star dot CPP and
Or you did GCC.
oh, did I? Thank you. I said G++, didn't I?
Yeah, you did.
All right, good. It all made sense in my head. All right, so there's our compile program. Not the end of the world. We can say, oh, well, that was pretty easy. Why do I need something better, right? But the reality is we can imagine this was a pretty simple little example with just some, a couple of C++ files and things like that. We can imagine that a much more complex program like an operating system has a lot more stuff.
Mm-hmm.
Okay, so that's where this idea of a Makefile comes out. So make is a program, and the make program expects something called a Makefile, and it has to be written in a certain way. So this Makefile is like an old, specialty format syntax. You could almost think of it like an HTML or an XML or a JSON, something like that. It was like, look, here is the language of Makefiles. And Makefiles are really complex, actually. You can do all sorts of stuff in Makefiles, but here's a simple Makefile to get us started. So inside of this Makefile, we define a macro. So CC, we're going to say we're going to use G++. So when we compile, we're going to use G++. Here's my source file. So again, this is a macro. You'll see us use it later. So here's all of my source code files just listed here. My executable is going to be called hello, just because I've decided that's what it's going to be called. I'm going to install my program inside of the bin directory that's in here, just because. All right. Now, the default behavior for this Makefile is to go ahead and using whatever this macro variable has, kind of like an environment variable. So I'm going to use the G++ program because this guy will resolve the G++. I'm going to compile all of those source code files with my output. -O is a flag to G++, be wherever my executable, whatever my executable is supposed to be called. All right. Then I have, let's just do the other half of that, make install would move that executable into that bin directory. And then make clean would remove that executable from that bin directory. So this is kind of like uninstall my program, build my program, install my program. All right, so this simple Makefile kind of has different directives. So if I go into bin right now, do I have anything in there? No, I don't. Okay, so if I just type in make, the default behavior for make will be that default section, this guy up here, and it's going to just compile and give me a hello. Okay, so I'm going to type in ls. Notice I have my executable here. All right, and I can run that if I want, no problem. I can say /hello, and there's my output of my program. Now, presumably, this is some amazing software application we've written. And, after we compile it, we want to actually install it in our system, presumably someplace that's in our path. So I would do a make install. This will call that same Makefile, but it will find the install label, and the install label says, go ahead and move your executable into the bin directory. So now I'll see that my hello is gone, but if I go into my bin directory, I have my hello in there.
Yeah.
Okay. And, I can run it obviously by saying bin hello, and there's my output. But now I just thought, you know what? I don't like this program. It's buggy as hell, or even more, it doesn't do anything actually in this case. I'll do a make clean, and that will remove that file. So now if I cd into the bin directory, I see I have nothing in there.
Yeah.
All right. So if we think about the benefits of a Makefile, as I start, so you kind of set up a Makefile initially. Then as you start adding features to your software, I can add another couple of source code files onto here. I can add some different command line flags here, so on and so forth. So as I make, additions, I make it so that it's convenient to compile and even test, my program. Because I can come in here and I can add I'm not BIing this, am I? So I can come in here and I can add another field called maybe run. And we can say run should just go ahead and do a $$exe like that.
Yeah.
So now I can do a make, which makes it, and then I can do a make run, which will run it. Okay, so I can use this Makefile thing to kind of conveniently do stuff with my program.
Yeah.
All right, kind of makes sense. And this is going to be extra beneficial to us. I'll just give you a little foreshadowing. We'll talk about that more next week. But if I go into our hello world, notice we got some scarier looking crap in here.
Mm-hmm.
All right, if we go into that Makefile, we see that we actually have to do some extra junk when we're doing our make using module libraries and stuff. This would be pretty inconvenient to type every single time, right?
Yeah.
So that Makefile says, figure out how to do it once, then you can just make it happen in the future. So it's a convenient tool for a developer, even though you have to follow a fairly let's say complex, very specific syntax. In fact, this indenting here, it's really picky about indenting. So if you go back through and you try to do some of this stuff using, I can't open Visual Studio Code right now, apparently. I'll give it one more college try. I don't know why that does that. What's the dealio? I know it'll fix it. If I reboot Linux, it'll fix it. So it's something with the virtual machine.
Yeah.
I'll try to mess with some settings. It's probably something with video settings. You're probably right. But down here, kind of on the bottom right of VS Code, is a thing that it probably says spaces:3.
Yeah.
You need to click on that. And then up top here, there's like a search bar that shows up. One of them says tab. You want to change it to tab 3 or tab 4 or something like that. Because what ends up happening is if you just press the tab key and it puts, it makes it look like it did a tab for you.
Yeah, then it's just your 3 spaces.
It's not actually a tab, and Make will break.
Yeah.
Make will scream at you and say, this is poorly formatted, blah, blah, blah. So it's like more anal. Well, Python's not that anal. Python just says, look, I don't care how much you indent it, but the amount you indent it needs to be consistent. If you want it to belong to an if statement, indent the crap underneath there at the same level. Makefiles are more anal than that. They say, look, you need to indent this the Makefile way, which I think is 4 spaces, but I think more importantly, it has to be formatted in the file as a tab. I think is the punchline. But in any case, as we make some of these, expect that we'll get some weird Makefile things, but the punchline is you just have to debug your Makefile once, and then once you kind of have it in the right format, you're off to the races.
Yeah, or you can just install the VS Code extension for Makefiles, right?
That's not what cool kids would do, especially if you
Well,
can't get the VS Code to work.
well, that that sounds like a you problem.
It might be. It really might be. It probably is. I run too many virtual machines.
I
Let's look at the settings.
don't
here.
know. Okay, so I have my computer set up so that I run a virtual machine and on top of like really stripped down version of Arch, so that I can just get as much performance out of it as possible, and then I just have it go directly through my RTX 2070. So
I'm guessing you're thinking here. I'll just put my Ubuntu to sleep. I won't actually reboot it. Am I able to make changes? Oh, I actually have to shut it down. So this isn't gonna really give me a test. Well, I guess we could test it real quick. I could do a. Actually, let's just see. Does it work this time? No.
I think Electron has some like basic like graphics acceleration, or even just Chrome, because Electron.
So you would say I should turn off 3D accelerations if I'm not using it, right?
Yeah.
Always use high performance graphics. Turn that off.
Yeah, because then VS Code won't try to use that and then break. It'll just use like the it'll use the most basic graphic or like graphics compatibility.
I'm assigning 6 processors to that and 16 gigs of RAM, and it's not even touching my system resources.
Well, I mean,
ridiculous. Like in an awesome way.
I mean, I'm thinking about getting like a few 256 gigabyte RAM modules put in my computer. I need a few terabytes. I run out of RAM too fast, so I need a few
no
terabytes
way that your
RAM.
motherboard supports 256 gigabytes of RAM modules.
Don't worry about it. I'll go buy a server.
The soldering iron, well, even that, the server just going to have lots of RAM banks.
Well,
I think right now, what is it? The biggest RAM chip that's like consumer viable is what, a 32 gigabyte stick?
Oh, that's consumer. I can still go on to Newegg and I can buy a 256 gigabyte RAM module.
Jeez. Right, so
it's pretty crazy.
It'll launch this time. All right, so that launched that time. Now let's try to recreate our problem. So we'll put our Ubuntu to sleep. All right, so now it's asleep.
Or you're gonna have to kill it probably.
Well, no, because I'm trying to recreate what usually happens.
Oh, okay.
Usually I have it asleep like this, and then when I have class or something, I go in, I just start it back up. And this is usually when I start having issues. But it's possible, like after multiple times of doing that, I put it to sleep and I shut my monitor off, whatever, that kind of crap.
Yeah, I would assume that it would start to break after a while.
But maybe it is that whole 3D accelerated stuff. Maybe it'll make life easier. So we'll see.
Tell me if it works for you.
I will. Have you seen any of my live streams lately?
No, I can't. Did you say? No, you said you weren't on Twitch. You said you were on Facebook.
I'm on Twitch now. I'm on everything.
Oh, you're on? You're on everything?
Twitch, I'm on Facebook. I'm on YouTube.
You got to give me your Twitch. I'll get the notification.
I'm guessing it's
twitch.tv/Mike Littman.
No, I'm guessing it's Awesome Fat.
Or Awesome Fat.
I'm opening it up right now to see.
Go to Awesome Fat.
Because I actually use,
there you are.
I use Restream.io.
Okay.
So today I'm doing this afternoon sometime, I'll probably do a secret made Saturday is what my advertisement. And now I have a sponsor.
You have a sponsor?
I do. I have this Korean company. It's paying me $400 a month. Because I'm the I think they like the idea that I'm like an older person playing this game that young people play, but I'm playing it from the perspective of like not just teaching the strategy, but I talk about like computer programming concepts while I'm doing it. Plus, I think I'm pretty funny. Um, and I make up crap and stuff like that. But yeah, so I've been every time I play, basically, I just start streaming with I use OBS and I stream with Restream.io, which allows me to stream to multiple platforms.
Yeah.
And so I'm still getting used to getting better at it and branding it and stuff. But I don't know, it's kind of fun.
I'll subscribe with Twitch Prime. Or no, it's just Prime Gaming now.
Prime Gaming? What's Prime Gaming?
Prime. You don't know about subs with Twitch Prime? I'll give you. I don't know how much money you get from Twitch Prime subs, but
No, I don't know anything about it.
Well, it's like I don't know either. I don't stream on Twitch. I don't know much about it. I just know that I can.
So I assume that you're a Twitch Prime member, right?
I am. Yeah, you get it with Amazon Prime. You can subscribe to somebody on Twitch, then they get some amount of money.
Oh, interesting. Okay, well, I'll have to look into it.
I think you have to get yourself monetized, but I don't know how you do that. So
I already know. Yeah, you have to stream some number of hours. I already covered that.
Okay.
I've already streamed, I think, something like 30 or 40 hours.
Yeah.
On there, I opened 80 packs yesterday, and made $11 over and above what I paid for the packs. So I got free lunch.
Nice. You gotta come play Gary's mod with us. We're doing that tonight.
I just still don't get Minecraft.
Well, it's not Minecraft. It's Gary's mod.
But it's still Minecraft.
No, it's not. Do you not know about Gary's mod?
I do. I think you showed it to me. It's still the game Minecraft, though. It's just
no. This is something completely different.
Remind me is it associated?
Gary's mod is like a it's like a Source 1 sandbox, pretty much. And then you just play sub games. So I
definitely know about Gary's mod, but in my mind I was connecting it to Minecraft.
I mean, you might be able to connect it to Minecraft. I don't know. So I think it's very different. There you go. You go get it for yourself on Steam.
Gary's mod.
Oh yeah, the Steam sale's still on. $5. That's worth it.
Well, mine says it's $6.69.
Oh, maybe it doesn't tell me the right price. Hold on a second.
I'm not logged in now. Maybe if I logged in, I would be.
Oh no, I'm just blind. $6.69. Okay.
I could buy the Face Punch complete bundle.
Oh boy.
I don't know where I heard about Gary's mod. I have heard of it before.
Yeah, I mean it's been out since like 2006. So this game is as old as me. Right. I'm actually older than it by like a few months.
In 2006. 2006 is the year I started teaching at Concordia. Well, that was after I had been teaching at Western Illinois University for 6 years. Hey, I'm getting old. It's bad.
You're an old man now.
Oh. All right. So same time, same station next week, and we'll write a module.
Sounds good.
All right, cool. Well, I will see you then. Look for my live streams.
Okay, I'll have my phone notifications.
All right.
I'll be watching. Okay, bye.
Bye-bye.